Hi, this is Presh Talwalkar. There's an interesting pattern if you multiply a number that has only ones by itself. If you multiply a number that has 5 ones in it by itself, you'll count up to the number 5 in order, and then you'll count back down to 1 to create a palindrome of the numbers in ascending and then descending order. This pattern will continue. For example, if you want to multiply a number which has 9 ones by itself, you would count up 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you would count down 8, 7, 6, 5, 4, 3, 2, 1. But what happens when you have a number which has 10 ones? How would you multiply that by itself? If the pattern continues, you would count up to 10, and then you'd count back down to 1. If you had a number with 11 ones in it, you would count up to 11, and then you'd count back down to 1. In this video, I'm going to show you a very real way in which this pattern does continue, and you could say this is an accurate representation of the multiplication. But since we write numbers in decimal form, we're going to want to carry over whenever we have a result that's more than 10. So when we have 10 ones in the digit, our actual result on a calculator will be slightly different, and the same thing happens for any number when we have more than 10 ones in the digit. And I'm going to show you how you can actually get to these results even though the pattern continues. So to show you how this pattern works, I'm going to use a method of multiplying numbers by using lines. I provided a link in the video description for that, and you can check out the method. I'm going to give you a brief explanation. So let's say you want to multiply 11 by itself. For the number 11, we're going to draw one line for each digit in the number. So for the leading one, we draw one line, and then for the one in the units digit, we draw another line. For the other number that we're multiplying by, we're going to draw lines in the opposite direction. So for this one, we're going to draw one line in the opposite direction, and for the other one, we're going to draw another line. To get our result, we're going to count out the number of intersections between the lines. On the very far right, we look at the vertically lined intersections, and we have 1. In the middle, these two intersections are vertically aligned, so we have 2 intersections. And finally, on the far left, we have 1 intersection. So our result of 11 times 11 is 121. So now we're going to try and extend this pattern. So to do that, I'm going to redraw this diagram a little bit. I'm going to bring in these lines, and we're going to have exactly the same diagram that's smushed in just a little bit. We still have 1, 2, and 1 as our result of 11 times 11. And the reason I'm doing this is now we want to extend the pattern. Let's say we want to multiply 111. We're going to add one more line. And if we change the second number to 111, we're going to add one more line again. So what have we done in this new figure where we're multiplying 111 by itself? Which intersections have we created which are new? Well, we created one intersection on the far left. Then we've added one intersection to each of the columns that we've already had. And then on the far right, we have one more intersection. So when we count up the vertically aligned intersections, we're going to start out with 1 on the far right, then we have 2, then we have 3, we again have 2, and then we have 1. So you can see why we have a very symmetrical pattern of intersections. And you can also see that we're adding one intersection to each of the existing numbers, and then we're adding 1 on the far left and the far right. So 111 times itself is 1, 2, 3, 2, 1. In fact, this pattern continues. I'm going to show you one more example. So let's say we wanted to extend this to add the number 1 to each of the numbers we already have. So we want 1,111. We're going to draw one more line for that. And for 1,111 and the second number, we do the same thing. So we draw one line for our first number and one line for our second number. Now, in order to use multiplying by lines, we're going to extend the lines we already have so that we create the intersections. And we end up with another lattice grid. So which are the new intersections we've created by adding 1 to each number? Well, you can see on the far left, we've started out with one intersection. So that's the one which begins our new multiplication product. We're going to add 1 to each of the columns, which we've already had in our previous result. And then finally, on the far right, we add 1 more. So when we count up the vertically aligned intersections, we end up with 1, 2, 3, 4, 3, 2, 1. So you can see how this pattern continues. If you wanted to add a fifth number 1, multiplying it by itself, you're going to add 1 more line on the left, 1 more line on the right, and it's going to increase each of the existing columns by 1, and then we're going to add 1 on each end. So that's why this pattern continues, where we have palindromic numbers that go up in increasing order, counting up the numbers and then counting down. So that explains how we get up all the way to 9. Now when we get to 10, you're going to see visually that this pattern will continue. If you were to draw out that lattice grid, multiplying by lines, you would see that you would end up with one column that had 10 intersections. So if you represented numbers in this way, you actually could argue the pattern would continue. But since in decimal form we never have a numerical digit that's more than 9, we're going to need to use carryover. So the column which has 10 is actually going to become 0. That's going to carry over to the left, so that the column which has 9 will then become 10. We're going to carry that over once more so that the column which has 8 becomes 9. So we're going to end up with the results 1, 2, 3, 4, 5, 6, 7. None of that's affected. That 8 needs to become a 9. The next two digits will become 0 because we have carryover. And then on the far right, we're still going to have 9, 8, 7, 6, 5, 4, 3, 2, 1. That's still the same. So similarly, if you have a number which has 11 ones, you actually would have, multiplying by lines, a diagram that goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In order to get a number which would match with the result on your calculator, we're going to need to use carryover anytime we have a value more than 9. So we're going to need to carry over the 10, the 11, the 10, and we're going to create, this is not too difficult for you to use carryover, you would end up with another pattern where you go 1, 2, 3, 4, 5, 6, 7, 9, and then we have 0, 1, 2, 0, and then we go 9, 8, 7, 6, 5, 4, 3, 2, 1. So you could use this method to calculate multiplying any number which has just ones by itself. So it's a kind of interesting way to see why, when you multiply a number just with ones by itself, you end up with this interesting pattern of palindromes. Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at PreshTellwalker. And if you like this video, please check out my books. I've provided links in the video description.